Hey, so I'm making this video because I had this idea of authenticator apps and how they are not perfect. So one thing that happened to me once was I see that the code is expiring, so I need to switch screens and I'm not sure if I can write this on time. So let me wait 10 seconds for the code to renew so I'm sure that I'll be able to write the code. And there's a problem with that, is because I'm wasting time. And so I thought that what if I could select the OTP code that I want, and after the time is up, it extends and adds another digit to it. So something like this. Let me search for authenticator app. Authenticator app image. Okay, this is a good example, I guess. So you see 772544 for Death Star Control Center, and it has like 9 seconds remaining. All of them are on the same interval of 30 seconds, I guess. Let's say, oh, okay, let me start typing. I'm looking at my phone and I'm typing. Let's say, for some reason, I'm a slow typer. I start writing 77254, and when I'm writing the last four, it switches to another one. It's like, oh, damn, now I need to delete all of this and write again. So let's say I could just click this, like tap this and select it, and it, once the timer is up, it just adds another digit. So it would still be 7725449, something like that. And I already inserted all of them, and I just need to insert the next digit. So I think I was thinking there must be like a safe way to do this in a logical way. So what I was thinking is, and I just learned about the nature of TOTP yesterday, and I was fascinated. I thought that this was something that, hey, you need to, the authenticator app generates a code, then you submit it to the server, then the server asks Google Authenticator, for instance, hey, is this code right? And Google says, yes, it is. But it's not the case. It's actually, they don't need to check. They just check for, there's a shared secret, and they generate the time, the OTP code based on the exact timestamp and time interval, let's say 30 seconds intervals. So let's say you have no Wi-Fi, no connection, and you go to your authenticator app on your phone and you open it. The codes that are generated there, they will be valid. So I didn't know that. But okay, so let's say I'm a slow typer. And it's like, hey, I want to log in to Facebook, which is blue. And it's like, hey, cool, want to log into Facebook. And they say, hey, give me the authenticator app, OTP. And then you open your authenticator app. Let's just put this in like red. And so log in, hey, credentials are good, give me the authenticator app, and then you go and see it, and then you get it back, and then you submit it. So this is something like this kind of flow. And I'm doing these lines that are not connected because you're not really interacting and submitting information over here, just seeing. So it's not like you're sending information that you have, you're just seeing information. So it could even be something as in like this. Okay, so let's say the OTP code was 12345 6. That's the OTP code, and then you press it, so it's selected, and whenever the time goes out, it adds another digit, and it adds a digit which is 8, and then you submit it, and then the mechanism would be like, oh, this was supposed to be 6 digits, but I got 7 digits, so I'm gonna treat the digits that are beyond the expected limit as renewals. And how would that work? And I came up with this idea. So let's say you didn't press it, so it created a new code. And the new code would be 111111 for the sake of simplicity. Oh, actually 111113. This is the new code that would be generated. Let's say we sum all of the digits together, so it's 1 plus 1 plus 1 plus 1 plus 1 plus 3. This is equal to 8. And it's like, okay, let's insert 8 over here. And let's say the new code that is generated afterwards is 2, 2, 2, 2, 2, 2. So the sum of this, and let's say you took even longer, and 30 seconds went by, so it generates a new 6 digits OTP code, which is like this. And let's do the sum. 2 plus 2, 4, plus 2, 6, plus 2, 8, plus 2, 10, plus 2, 12. Okay, now we have a 2-digit number. So it's 12, so 12 equals 3, because it's 1 plus 2 equals 3. So we would add 3 to the party. So this would be, and it would go like on and on and on, like that. And this is the creation mechanism, and this would be the validation mechanism. So I use the TOTP library, which is very simple library, but very efficient library for OTP codes. And I created a function called compress sum, which is a function that does that thing that I showed you. So let me show you. So compress sum of 111111 and b is equal to compress sum of 222. So let me just run this with a debugger so you guys can see. So a is equal to 6 and b is equal to 3. And this uses recursion. It's a very simple implementation, actually. And you could do it without recursion, of course. But anyways, I wrote this function, and what I did was I changed the code of the PyOTP library. So I added the same compress sum here, and what I did was there's a verify method function, and it checks. So when you initialize the PyOTP, you just pass it a secret, and there's an optional, that there's the interval, which I chose to be 5 seconds. So every 5 seconds there's a new code generated, and the older code is not valid anymore. And I modified the verify function to include this piece of code, which is if the length of the OTP code is bigger than the number of digits, and when you're initializing the PyOTP, there's a parameter called digits, which defaults to 6, which is what we're mostly used to. So if we pass it a 7 or a 8 here, then we do something. I'm just doing this assert valid window equals 0 just for the sake of this demonstration. And we just do this. Oh, let's check if the last digit is good. So we get the, okay, so this self.at will tell me, oh, what's the OTP code right now? What would be? And then we just need to compare the submitted OTP code with the OTP code that's generated right now. And we check that, we do the compressed sum of the OTP code of right now, and we check if the digit is, if the result, which is just 1 digit, is equal to the last digit of the submitted OTP code. So if the submitted OTP code is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, it's going to check if 9 is equal to the compressed sum of the current valid OTP code. And if that is true, if that is false, it's just return false and say, hey, the last digit is not good, so it sucks. And then, but if it's true, what it does is it starts verifying, and this is using recursion, so it's calling the same method, same function that we're on right now, verify, and checks, hey, let's check the remainder OTP code. So if the OTP code was 1, 2, 3, 4, 5, 6, 7, 8, 9, it's going to check for till 8, and it's going to be like, hey, check for this, and the time that you should check for, and by the way, the for time parameter is optional, but then if it's none, it's then set to now, which is used to generate the self.at. So check it for the current time, but 5 seconds before, which is self.interval, because I defined it as 5. And then it's going to do that again and again and again. So we're gonna give this a spin. Actually, so I'm gonna run this, and it's like first OTP code is this one, and then it's gonna generate the new code. Let me go back. So it generates the first OTP code. This was from the README, which is this one, and then generates the next one. So I slept for 5 seconds, which is what I defined to be the interval, and then it generates a new OTP code. So, and then I do the compressed sum of the new OTP code, which is equal to 8, and then I just add 8 to the first OTP code. So we have 800212, 8. Perfect, like, and it's a 7-digit. So now we come here, and it's like, hey, is the length of the OTP code bigger than 6? Yeah, it's 7. Okay, so let's check if the last digit is good. So it checked for this thing. It's like, okay, good, and then convert it to string. It's already a string, so, and we just do the compressed sum, which is 8, and then we check if this is equal to the last one, which it is. Okay, if so, this is true. Perfect. And now we check for the next one, and iterates again, and this is the next time, and then the OTP code now is just 6 values, and the time delta, the time that we're considering is 5 seconds before the time we considered when running this piece of code right now. So it's just going to check this, and this is going to be true. It's using util string equal for some reason, which I am timing attack resistance string compare. Okay, this is extremely relevant. So I didn't know. Well, every day you learn something new, don't you? Okay, good, perfect. So return strings equal, and so I go to the terminal, validation results, which is what we have here, is true. So yeah, great. So this code works. So if we want to do it manually, well, we can just replace this with print, or we could even do this with 2 of them. So new OTP code, compress sum, longer code, and then let me just do this again. I'm just gonna copy this. I just need to change some things. Time sleep, new OTP code, and then next OTP code, compress, and then longer. In this case, longer will be plus equal to the compressed one, and then it will be 8-digit. So let's try this. First, next, already done, which 5, and then we have a 7-digit code, and this now 8-digit code. So first one is good, second one is good, last one, nailed it. It works. So this is my proposal on improving something that is already good. But you might think, oh, but this brings security concerns. I don't think so. So I already did the math. So let me just start a new one. So let's say you have 6-digit code. So the potential combinations will be 6 factorial, which is 6 times 5 times 4 times 3 times 2. 720 codes. And let's say you have a time interval of 30 seconds. So 30 seconds. So you need to, if you wanted to brute force, you need to brute force 720 values in 30 seconds. And with server-side communication and things like that, that doesn't really work. If and then you would get blocked and things like that. So let's say you add an extra number. So this would be 7 times all of this. So it increased 7-fold, and the time only increased 2-fold. And if you add another digit, it's just the time increases by 3, and it doesn't duplicate the time after it was already duplicated. It just adds another one. So the longer you wait, the harder the code gets. And I believe they only made it like 6 digits long just so people wouldn't be, they could memorize 6 digits. As in quickly, it's short enough for people to memorize and long enough that it doesn't get brute forced. But in this case, I don't see any security risks added here, especially with the compressed thing. I thought about the compressed sum as a non-obvious way to do this. The other approaches could be done, but it's pretty much the same, I guess. We could do multiplication. We could do something like, let's multiply all the numbers together, then we multiply them all together, until we get just one digit. Although that could take longer. That would take longer, necessarily. But yeah, this is my suggestion, and I hope you guys enjoy it, and I hope you guys feel like it would be a good addition, and hopefully we will have extendable TOTP codes in the future. Thanks for watching.